Good afternoon. I'm Hugh Dyer, an Associate Director in RSK's Geosciences business. Welcome to the July edition of our 2024 series of Down to Earth webinars. These talks cover a broad range of subjects through the year and are available afterwards on our YouTube channel alongside previous talks. So our talk today will be given by Dr. Paul McMahon from our geotechnical team, giving us a look at the economic design of foundations in clay soils. This is the second of our geotechnical talks this year. But firstly, a brief note on housekeeping during the talk. All attendees' microphones are automatically muted through the webinar. During the presentation, you can post questions online, and there will be a question and answer session at the end of the presentation. We'll get through as many questions as possible afterwards. Those that can't be answered due to time constraints will be answered after the webinar. Shortly after the webinar, you'll receive a link to a short survey. If you could take a few minutes to provide feedback, please, so that we can improve on future webinars. Now, please let me introduce our speaker today. Dr. Paul is a chartered civil engineer and a fellow of the ICE. Paul is an associate director within RSK Geosciences and has over 23 years experience in civil engineering contracting, house building and geotechnical consultancy. Following his PhD in cement stabilized limestone in 1985 with the University of Sunderland, Paul also has 25 years of academic experience as a senior geotechnical lecturer at the universities of both Bolton and Salford, and was operational lead at University of Bolton prior to joining RSK in 2022. Through both his, so I'll hand over now to Paul to give us a review and the considerations of foundations in clay soil.
Thanks very much, Hugh, and welcome everybody online. During the presentation, I will turn my camera off so you can see the slides fully, but I'll turn that on at the end. So you'll notice on the slide here that it's got slido.com and the code number DTE for Down to Earth. I'm straight away going to ask you a question, if you wouldn't mind just answering this question for me. So what factors do you consider important for the design and construction of foundations in clay soils? So slido.com and the code letters DTE should get you in. I'd appreciate if people could put some words in. Brilliant. Well, that's fantastic as a snapshot, and I realise that 30 seconds isn't a long time for everybody to contribute, but I do appreciate you putting those words in. If I turn to a slide that I prepared earlier, as they say, then I think most of the comments that you put in probably fit into one of those boxes. And the comment from me at the beginning of this talk is that it sounds simple, foundations in clay soils, yet it's such a complex subject area and there's so many different avenues you could go down, and I found it very difficult to put this fully together to try and address everything that somebody might be expecting. So I think without any other comments, I just say that if there's anything that wasn't covered today when I get to the end, then by all means do contact me and I'll do my best to deal with you one-on-one, or the questions at the end if it's appropriate and there's enough time. What this webinar set out to explore, based upon the publicity information that went with it, was looking at current and likely trends on foundation depths, the effects of trees on foundations within developments, and what the impact of increasing geographic distance from the southeast of the UK is. And I think coming from a geotechnical background, One is quite clearly thinking about the geology, about the geotechnical aspects, about what clay is, how it behaves, what foundation types are all about. How does the clay heave? Why is it important? What kind of volumes of heave might we get? And then linking in with future way of thinking, how do we carbon cost this, and do we compare different foundation types? So there's a lot of factors come into it. An interesting quote in the recent National House Building Council Future-Proofing Note NF93 is that developers might consider increasing foundation depths now to accommodate future predicted climate resilience, rather than waiting for the standards to change, which is quite bold. And I guess, how far do you go? Because if we are thinking of net zero considerations, then increasing foundation depths to a significant amount would obviously give us a higher carbon rating, and it might not be needed, I suppose, is one way of looking at life. Or we might consider alternative foundations if we're getting too deep. Turning to clays themselves, clays are microscopic, 2 microns in size, which is 2 by 10 to the minus 6 meters, so very, very small. And clays are formed of various clay minerals. Without this becoming a geological talk or a mineralogical talk, for me, the key is that you've got kaolin that's a little bit less plastic compared to illite montmorillonite, perhaps. And it's all to do with the silicate alumina sheet ratios, so that the kaolin has got a hydrogen bond that's a bit stronger and it repels water from trying to enter the void space between the particles or the mineral groups, whereas the illite montmorillonite group traditionally have got a craving, if you like, for water, so they will swell a lot. And I guess that BGS and others have looked at the variation in moisture with depth, and typically we're thinking the upper 1.5 to 2 meters, but there are reports of going down as deep as 5 meters, and we know that particularly if you're near trees, that's the case. And if we are going to have much drier summers and much wetter winters, then how will we accommodate for this within our overall designs, and how do we, as the reference says, future-proof? So looking at, again, BGS have done some predictions and modeling based upon the geology and the anticipated climate change, then the impact on buildings may be along the lines of this drawing. So on the left-hand side, 2030, and on the right-hand side, 2070. And I guess the things that we need to be aware of in this context is that 6.5% of properties are expected to be affected by shrink swell by 2030, as opposed to only 3% in 2020. And if you go to 2070, this is expected to rise to 11% of properties. I think you can see the trend in this diagram that the sort of area of risk, or the area of impact, is in the southeast of the UK. And if one hovers on the left-hand diagram there for a second, the 2030 is as shown there now, and then 2070 back to 2030, 2070. So I'm just hovering that to show you the difference, and I would say that that represents in the southeast possibly a doubling of the area of affected properties. So that's just for food for thought. Of course, in that southeast area, we've got well-established BGS geology of the expansive clays in that region, or otherwise known as shrinkable clays. And in particular, the formations highlighted there, the Gault, the Lias, London clay, Oxford clays, and the Weald clays, pretty famous in geotechnical terms in terms of their problems, I suppose, for foundations and for general earth activities involving an expansive clay against the structural elements that might put pressure onto that structural element, and that needs to be taken into account. In 1991, £540 million is reported to have been the cost of the drought. I can recall 1976 there being a drought that I think first maybe has introduced a lot of these concepts of foundations in clay requiring to be deeper, particularly near trees or to areas where trees were removed. In 2003, 2006, after heat waves, there was a peak in claims again. 10 million households in July, September 2018, £64 million of claims. March 2020, £363 million of damage after storms. Significant subsidence-related claims were expected following the summer of 2022. So I think we all can spot the trends and we're all aware where the impacts are likely to be. Turning to the moisture content and volumetric moisture content of a soil now, because as a geotechnical person, one would think this way. So one generally expects even your clays in the southeast of the country might be in the natural moisture content range of 18–24%, that sort of range, if there isn't a tree impacting it. And from that particular moisture content being a mass gravitational calculation, the first point is that there's a simple test to do. Put it in the oven, dry it, and you get a moisture content after an overnight drying. That moisture content can tell you quite a lot about the clay. So if we assume the specific gravity of the solid particle is 2.7, then the void ratio of that soil would be between 0.49 to 0.65, where that void ratio is the volume of the void space to the volume of the solids in the soil. And what that's telling you is that the soil volume is getting up towards half of the overall volume. It's probably a third to a half. So that's a lot of void space, and that void space is full of water. And if the water changes in its sort of state, either gets wetter or drier, then you're going to get a volume change, and it'll be a significant volume change. So that's the mechanics of it. If you look at volumetric water content, because specific gravity of solids is very much more than water, and this is worse because the overall volume change in the soil can be 40 to 53%. And that's making an assumption of the bulk density being around about 2,200. So it's a sweeping assumption. But what I'm getting at is the calculations can be done to check what the current state of play is of your particular clay on site. And we can assess then whether that particular site requires more detailed design or not. London clay is regarded as being highly shrinkable and maybe is uniform. Certainly many people would think that. And so when one looks at a BGS report, looking at the overall volume change in London clay, you might be surprised to see that London clay has got quite a variability. So from the sort of western side of the London clay deposits, we're down at maybe medium shrinkability. Over the significant part of the central London area, we're definitely at the high, but there are some fringes right to the east where we might get as high as very high shrinkability, and there's pockets, so that with a detailed investigation one can pick out there's the sites at risk, or likewise the sites where it doesn't need to be as deep if that's what we're looking to do. So I think understanding that is important. Another thing that's worth looking at is the typical variation in the moisture with depth, because that's what we're talking about, is get to summer, dry summer and a wet winter. But what is the range in the moisture, and therefore what's the range in the volume, and how much shrinkage and swelling might we expect? So here's a well-established sort of plot that one might get from ground investigations at different times of year. And so what we've got on this diagram is overall near to surface level at 0.4 meters below ground level, there's about 17% change in volume between the summer and the winter, but down at 1.4, there's no change. So for a conventional foundation below just a grassed area in the southeast of the UK, probably in around what 1.4 meters takes you below any change in seasonal variation. This has not got trees nearby. But you could possibly say that at the typical foundation level of 1 meter for a high shrinkable clay soil in the southeast, then a meter would seem to be a reasonable foundation design depth. If you then look at the impact of a tree being nearby, then if you've got an oak tree on that site, then you can see there a significant difference in the overall behavior, and therefore down at a depth around about 2.3, 2.4 meters, there's a 21% volume change, which isn't much difference to the 17% on the left. but it goes down to a significant depth is the point. And you need to get down to 2.8 meters on this particular diagram to get to the point at which there's no variation in the seasonal shrinkage swelling. And I suppose that it's also worth saying that all trees have different effects. We've got high water demand trees and lower water demand trees, and all of this is documented in a very comprehensive set of NHBC chapters with a lot of guidance in there. And pretty much everything that's in this talk today can be gained from that. I do add a few extra things in, and I'm not intending at all here today to go through all of the NHBC sort of chapters, because that's just prohibitive on time. And again, all of this is also thinking about the overall Met Office predictions on the climate change to 2070. Now, looking at overall moisture content, this got me thinking, you see, because it's like, how dry are we really going to go to? And how wet will we go to? So if we think about clay behavior, the clay will reach its liquid limit. If it gets to a liquid limit state, it's not really worthwhile. It's not usable as material because it's liquid. At plastic limit, there's just enough moisture in it to be workable, and we like soil if it's in that condition because we can use it. And if you then look at the difference between those two moisture contents, and we call this the plasticity index, correlations can be made with that. But the other thing is that if we begin to go drier and drier, then shrinkage begins to take place, and we might be intending to follow that green dotted line if we thought there was a linear relationship. But you'll notice there the black line tends off to be a horizontal position because there is a shrinkage limit at a minimum volume in the soil, below which you won't get any further reduction in the volume. So once you get the moisture to a certain level at the shrinkage limit, you won't get a reduction in that void space, and you get no further shrinkage. Now, how far between the plastic limit and the shrinkage limit will the soil get is the question, really. So that one might also talk about shrinkage index, by the way, because some research does indeed talk about that and tries to draw correlations, which also can be useful. And another little thing to just mention is that once you get down to that shrinkage limit area, then we're now talking about this void space within the soil. As you go up towards plastic limit, all of that void space is full of water. So even though we're down at dry end, it's still actually full of water. And I suppose that what we're really trying to do here is predict whereabouts will we go with the summer figure between that plastic limit and the shrinkage limit. So I turn on to another. So and again, these relationships exist at different depths throughout the soil profile. So you could get the same relationships all the way down the soil profile, at a meter, at 2 meters, at 4 meters, etc., until you get to that depth of no seasonal variation in the moisture. So with that in mind, I just looked at this diagram again and I thought, well, how much deeper will we get? And I'm not claiming here at all that this is going to be right. I'm just saying that, in my opinion, we've got an original depth of 2.8 meters here where we've got no variation between the summer and the winter. But in the drier summer, what will the shape be? We know it's going to be to the left of the original. How far to the left? Well, looking at typical shrinkage limit values and looking at plastic limit values and assuming you go about halfway there, I estimated it could be somewhere in the region of about 8–10%, that sort of figure. And so I just drew a line there just to see what that might do to interpretations. And then on the wetter end of life, then you might think, well, can you get much wetter than wet? Is an interesting way of putting it. There will probably be some capacity for more moisture, but for that to happen, there has to be swelling. And down at 3 meters in the ground, I'm not really sure how much swelling you will really get. Near to ground level, you'll get swelling. So maybe that diagram isn't very accurate, but again, I'm just trying to put some sort of theory to it to see what do we get with. And if that was an accurate representation, that would be talking 32% volume variation. And therefore, if you're then also looking at the point now at which you've got no variation in shrinkage and swelling between summer and winter, then that could be 3.4 meters. So are we saying that a 10% increase in volumetric moisture content might give a 20% increase in depth. Again, I'm not claiming that as a design at all, but in the context of the very first question that I posed from NF93, how much deeper should you go if developers are, encouraged to go deeper now before the guidance comes in, then that's just a question for everybody to try and answer rather than me to state it. And this, of course, does indeed assume that the oak survives dryness, which is me just intriguingly wondering about what would happen. And of course, if the oak did disappear, then of course the soil would all wet up anyway, so we get a heck of a lot of swelling taking place, and that would be another problem. So there's always a problem. Looking at overall headings and things that might be linked in with foundations in clay soil, well, we're really looking at what's the fraction of clay present in the soil that's going to influence shrinkage swelling, and that's traditionally by looking at a modified plasticity index, which is the material less than 425 microns in size. We'll be looking at the tree species and then water demand and how far away from the foundations are they, and the mature height of the trees, and whether they're early on in their life or later on in their life, and all of that is in the NHBC guidance. Then how far from the southeast are we? Do we need to put expansive protection into the floor slabs that are going to connect in some way to the dwelling? It depends on what kind of floor I'm talking about there, as well as a direct connection. So rather going to be thinking, could we really use ground floor slabs bearing onto the expansive clay? Maybe it's not a great idea. So are we talking immediately going down the route of suspended floors? Well, probably, unless we're a long way away from the tree and we're happy for moisture content testing, the clay hasn't been impacted, of course. So by site investigation being thorough, one could actually check what's the current state of play of my clay in terms of its moisture in depth below the intended floor slab level. And then are there other foundation types we could use? And indeed, what about buried concrete? And so I'm not going to go through everything on this slide, and these slides are indeed included when they all go online, so people could look at these at their leisure if they've not seen already. But that's directly from the NHBC chapter 4.2, and it's just really suggesting that if we've got a modified plasticity index above the limits of the 10 to 20, 20, 40 and above 40 range, we're going to call them potential for change low, medium and high. Here's again a table of different tree species and high, moderate and low water demand from the left to the right hand side of that diagram, and depending on the particular tree species, the mature heights, and from that information one can design the foundations. Something that's really useful that possibly not everybody knows about, but certainly worth having a look at, is the NHBC app. It's well worth a download and have a bit of a play with that. It is quite useful because it can allow you to attempt to recognize trees, although an arboricultural survey and an expert doing that survey would be the preference always. But if you're trying to take a first design stab, then you can use the app to do that. And that will also help you to determine the distance away from the tree you are and the height of the tree. So it's got a sort of design tool built in with that, and I think it's well worth you downloading and taking a stab. It's a free download. And then I guess that the overall sort of implication here now is that in looking at the design of the trees, it's looking at how close to 50% of mature height is the tree when you're assessing the impacts, and then you will use different charts and tables to come up with recommended design depths. And you'll look at cases for where you might have a tree going to remain, new planting of trees, or where you're going to take a tree away. And indeed, the NHBC guidance goes through that in detail. There's not enough time here to go through all of this, as you're probably very familiar, I would assume. So if we've got a tree that's going to remain, and we've got an original ground level dotted red on that diagram, so to the right hand side there, there's potentially a cut in level and then an excavation for a foundation. And on the left hand side of the diagram, there's a little bit of infilling first, followed by a trench down, and the dimensions that one are going to use to design the foundations from dimensions A and B and the NHBC guidance are as per that diagram. Then if you're going to have a tree removed, again, it's a very similar diagram, but it now shows you A and B dimensions important on the right hand side where you've got a cutting, and on the left hand side dimension A is the one that you're going to look at where you've got the filling. And then if you're going to plant a tree, again, the A and B or the B, you'll notice on here it does refer to table 3A and table 4 and particularly column B. And again, I'm not intending to go through all of that, but I just thought it was useful to show you typical table 3A here, so that if the tree is at 50% of mature height or not, then there's certain dimensions and distances of zone of influence on the bottom of that chart that one would use. So 1.25 times the mature height if you've got a high water, or 0.5 if it's a low. You can see there that the importance of knowing whether the tree has a high water demand or a low is huge, because the range of influence on the soil is significant. That tree with a high water demand in a drying clay will do its utmost to get at the water because it needs to live, and so it will generate a huge network of suction within that clay and have a significant zone of influence. Here's a set of design tables that are quite commonly used in the NHBC designing of foundation depths. So I just thought that if I used a simple example, so if I had a tree height of 16 meters I was going to use for design. So, and if I had a high water demand tree, it was a broadleaf tree and it was 9 meters away, then from those two circles highlighted, the 16 and the 9, that will give me a design depth of 2.4 meters. Notice on this graph that this chart rather that the maximum depth there is 2.5 meters, and you'll also notice the note that says that anything that suggests greater than 2.5 meters should be designed by an engineer. So this will require a structural assessment. So you can't just go beyond 2.5 meters. And you'll notice on the bottom of the graph that there's nothing goes less than 1 meter, because frankly, if you're not in that zone where you've got numbers, you're outside of the zone of influence to the bottom. So the minimum foundation depth applies for the particular soil type you're in. And so if you're in a high potential sort of shrinkage soil, as we are here, then that depth will be 1 meter. If you're in a medium, that depth would be 0.9 on the other charts, and it would be 0.75 if it was low. Now, if you had a coniferous tree instead of a broadleaf tree, then again, the 16 meters tall tree, 9 meters away, I know that might differ because a coniferous tree was probably inherently going to be taller, but just to give the numbers here now, then this is suggesting that a foundation depth of 1.2 meters would be required. Taking the point about distance away from the southeast, to some extent this probably has a little bit to do with anticipated climate change. We're aware of the geology. The geology itself will make the shrinkability of the soil be high shrinkage design, and the tree charts take that into account in the way in which they put the depths forward on the chapter 4.2 design charts. But the principle generally is that for every 50 miles away from London, a relaxation by 50 millimeters on the maximum foundation depth required according to the charts. So we're still looking at the minimum shrinkage depths, but if you've got a tree impacted design, then you can reduce the depth requirements by these factors, taking recognition of the fact that we're further away from the high climate risk change part of the UK in the southeast. Again, I've just put here the chart for the BRE design of concrete. So based upon 2:1 soluble extracts or total sulfates and knowledge of, and just knowledge of those two numbers, one can then use the design chart to come up with a grade of concrete that you'd require to resist any attack of buried concrete in contact with these soil types. And so if I look at very quickly heave precautions and alternative foundation types, then if you've got underslab voids, then that will obviously mean that the floor slab itself isn't in contact with the expansive soil below. And there's minimum void dimensions that's given in the NHBC guidance that one has to be aware of, and it does vary depending on the soil type. And of course, suspended concrete cast in situ floor slabs depends on how you form the suspended floor slab as to whether or not you have to use particular products that will give you that void space. So collapsible so materials below to ensure you do get the required minimum floor space void, even if it is a suspended slab. And I guess the careful design of the pile connections, that you know, where you've got the floor slab connecting to the piles, those connections have to make sure that you've took any swelling effects into account. That might also include compressible material on any vertical concrete faces, because it could be a lateral thrust from the expansive clay material. Then if you're looking at other foundation types and considerations for site infrastructure, I just produced a list there that again isn't, these are all in the, again, the NHBC guidance notes. I think that, you know, trench fill, pier and beam, so really just a deep trench filled vertically to form a pier and then put a beam on top of that, or put an actual pile in the ground instead of a pier and then put the ground beam on. A raft foundations provided a significant granular cushion to ensure that you've got enough protection against any expansion, sort of trying to lift the concrete floor level up. It goes without saying that on schemes where we do have trees present, it can get very awkward when designing paths and driveways and try and protect those so that they stand the test of time, and drainage runs as well, in terms of you know, laying them perhaps to steeper falls than usual. And if you've got retaining walls, if you've got difference in ground level, then all of these things will require careful design consideration. I think that going without saying, there's a lot of good guidance around. The NHBC has got an awful lot of good stuff out there that's well worth a read. It will take you quite a while to read it. I guess that there's also a lot of experts around that can help you sort of get the right designs for your scheme. Added to that are various documents and British standards that are around that again one can use in terms of your foundation designs, and in particular now beginning to look towards carbon costing and working out how one should estimate carbon costing. And is that becoming important to prove that considerate developments will have a you know, a lot of care and detail to the carbon weighting for the future schemes, and I'm sure that's a credible thing to be doing. In carrying out the guidance, I know that NHBC consulted a lot of developers, and I think you'll see some high percentage numbers here in terms of developers certainly recognising, amongst all the other target groups for the survey, there's a significant impact expected from all of these carbon impacts or the climate change impacts, and there's certainly things that we do need to take account of in design. And just to make you aware that this is something that is now being offered within geosciences, that the credit method of assessing carbon are different types of foundations, and there's almost like a break-even point between a certain depth where strips will become unviable from a carbon scoring perspective instead of piles. But there's ways in which one can assess on a site-by-site basis what the carbon scoring as the different foundation types are, and that's something we're really keen to, you know, do more work with different developers. And likewise, foundation zoning plans and looking at topographic surveys. So topographic survey, I believe, will be the next down to earth talk coming up in about a month's time. So look out for that one. And in the zoning plans, then one can, based upon knowledge of the soil types, come up with suggested foundation options, and developers may well like to have that approach in design lives. So in conclusion, Future-proofing for climate. Really, it's hard, isn't it? A judgment call on how much deeper should you really take a foundation on the potential for there to be a future problem. And I can't answer that question in terms of, I don't know the advice. My instinct tells me to go a certain distance towards shrinkage limit, but how far towards it to go is a difficult answer. I'll tell you in 2070. Well, no, I won't, but other people will. And then increasing the depth will indeed increase the carbon costing. But you could argue that could be a short-term carbon cost, because actually, if you don't put future-proofing in, because of maybe carbon as the reason, and I'm not knocking carbon, we have to look at carbon costing. But if there is going to be a genuine risk of a future impact, then the rebuild or the extra works required to retrospectively do something to a foundation to make it viable is probably in itself going to be a huge carbon cost. So, and again, I don't know how to begin to attempt to estimate those numbers. I'm just aware that these are things that one will have to take into account in the future. An extensive guidance does already exist, and my advocate would be carry out moisture content tests more, simple tests, closer to trees, further away from trees, at different depths. So more testing of the soil, but simple tests. It doesn't have to be complicated, and that will actually help no end. Years ago, I remember a site where there was an orchard of cherry trees, and the trees were culled before a winter period, and then moisture content depth profiling was done, and then after about 9 months it was revisited, and the zone had actually reduced, and therefore there was a reduction in the economic foundation depth. So there are ways in which simple designs and just testing what is your actual soil moisture content now will generate an improvement in the overall design cost. And I guess that the call would be really for monitoring the moisture variations over time. We will have to be prepared to adapt designs in the future. And I think that takes me to an end of my talk. So I will put my camera on and invite Hugh to come back on for any questions.
Well, thank you, Paul. Yeah, that was really, really interesting talk. Some new perspectives in there. I'm sure we've all learned something. We've got a number of questions that have come in through the portal. So if I run through these now. First of all, what do you do if you have a tree nearby? So this is looking at the NHBC guidance. If you have a tree nearby that is not on the NHBC tree list.
It's okay. Well, I mean, if there isn't one on the list, then an arboricultural survey, I would say, would be the first port of call, because they could obviously then rank it into a category in terms of its expected mature height and its water demand in particular. And we do have people within RSK that can do that kind of survey work, really. So I think the NHBC is pretty comprehensive, to be quite honest. But if there was a rare situation where there wasn't a tree identified, then you would have to go down the route of an arboricultural survey.
And try and get them to classify it as closely as possible to an existing tree.
Yeah, I mean, you've got your broadleaf sort of leaves, and so, you know, you would be able to, like, an arboriculturist would give an assessment. You would also have that ability to do the moisture content depth profiling near to the tree, and that would actually give you, it's a bit like, how do we get these standards in the first place? And a lot of this work does go back to research in the late 1990s, where people were doing exactly that. We're looking at an existing tree and taking moisture profiles a lateral distance away and at different depths, and almost producing a moisture map, a moisture contour map, and then you can look at zones of influence. So what we're doing here now is we're using an expected zone of influence to then say that near to this tree, theoretically, here are the zones we expect. But if you're on site were to carry out the measurements, then you could either prove or disprove that. You would have to obviously get a lot of testing to be able to say go against the normal guidance, but it could be done by negotiation with the NHBC and other experts. That's something that I have done before. We do need a lot of testing, but it's simple testing, cheap testing. It's not expensive.
I suppose that leads on to one of the other questions that I had. Is there a way to monitor soil moisture content in situ through an installed device?
It's a great question that I actually don't know the answer to.
No, I was one as well.
There are probes that one can assess, but whether or not you'd install them routinely is another question. There will be ways of trying to measure conductivity, for example, or some of the fancy probes will give an indication, but I don't know whether that actually be more expensive than just doing spot checks. But look, it's a good question.
And also, it's difficult to get the comparable results to a moisture content lab test. Actually, to get a real big soil out,
because it's installing the instruments is also fraught with errors, really, or difficulty in getting instrumentation into the ground without the presence of the instrument affecting how it measures. That's an art in itself that you could probably do a talk just on that, actually.
Yes. Another question, I think you covered this to an extent. With the predicted changes in soil moisture content due to climate change, is there a risk that foundations designed now using the existing guidance could be impacted by greater soil moisture variation in the future?
Yes.
So designing for the current guidance, are we setting ourselves up to have, which you did cover to an extent?
Yeah, I mean, look, I do know that there's this is being looked at currently, isn't it? So that there will be guidance coming in, and as I hopefully articulated in that talk, I don't have the answer either currently. But people with access to all of the huge volumes of research data, I forget the figure now, but in my reading around for parts of this talk, it's a crazy amount of data. There's maybe, I think it's in the order of 60,000 test results in London Clay alone. So there's a huge library of data about the way in which the shrinkable clay soils have behaved so far, given different climatic changes annually. And therefore, from that, you can predict how it's going to go, assuming you get the right temperature predictions by 2070. That's the problem. It's like, what is the temperature going to be? If you know that, and you think that's accurate, then you could probably do the designs. And I'm pretty sure that's, I can't speak for NHBC, but I would have assumed that that's what NHBC are currently looking at to work out how to modify the guidance. And when, I mean, you're going to have, I don't know, you're going to have the 2040 guidance and the 2050 guidance, or because it's like, how far into the future should you design? What's the design life of a house or a structure? So it's a brilliant question again.
It's a difficult one, really, isn't it? Is it worth looking at scoping an initial survey at a very early stage, such as the EIA stage, to provide an early indication of shrinkability across sites identified as having clay soils?
Personally, I think that's quite a good idea. I mean, it isn't a huge amount of money. It does involve intrusive works to get samples, but a low-cost exercise and then just moisture content testing with some Atterberg limits, it's not a huge sum of money. But I don't know whether there'd be an appetite for people to do that. I mean, at that early stage, quite often sites are speculative and people haven't decided to buy them and are just trying to assess what costs might be involved. So I don't know whether there is scope for doing a limited amount of testing at that very early stage or not, actually. But it would be a good suggestion.
It's the viability and how close the viability is that I suppose how crucial is the likely foundation depth going to be at that stage, and actually is the cost.
I tend to agree. I think you would find very quickly whether or not the soil seemed to be close to its recognised natural moisture content, or whether it had been significantly affected by desiccation. So it would give you a very immediate alert to the fact, yes, you're going to have problems, or it could give you a bit of confidence that it looks to be about the right moisture range. So that could give reassurance, I suppose, and it could help set costs a bit quicker.
And I suppose linked to those two questions, you talked about the soil moisture content profiles, but obviously that looked at a summer and a winter. So a lot of the site investigations tend to be a one-shot, go there and take all the samples. To get those moisture profiles, are we looking at then doing site investigation close to the trees and further away from the trees, and then also in different seasonal conditions?
That's a brilliant question as well. I mean, to be honest, there's a lag in the time it takes for the moisture change to take place as well. And because we're dealing here with a soil of a very low permeability, these are sustained changes over a long period of time. So they're not like a short-lived change. So you ain't going to get one sudden wet summer, make the clay all suddenly wet or suddenly dry, if you get me. So it's going to take a sustained period of time for that significant depth to reach the stage is that it would be in its worst case. I'm not sure if that explains it well, but there's a lag in that time. In the same way as if you're loading a soft clay, then you'll have a consolidation with time, and it's not going to be in weeks or days, it's going to be months and years. So it's the same with the moisture variation, really, that it isn't going to be a short-term thing, which makes it hard to research it.
Yes, no, I can see that. So you're looking over a period of years of wetter summers. And
but the good bit is that you know the current state of play of that soil given that climatic change that we've had recently.
Yes, yeah. Okay, a couple more questions, I think. The guidance focuses on the influence of trees. Is the influence of crops on soils underestimated, and what impact could this have?
Good question as well. Well, I know that it talks about trees. It does talk about hedgerows and shrubs as well. I don't believe it talks about crops, and I'm not really an expert in crops actually. So
no.
I think it depends on the root depth and the suction envelope of the particular crops. But it's a really fascinating question.
I mean, this could inform your next PhD, really, couldn't it?
Kind of, yes.
I think there's definitely a PhD in there, because theoretically, if a piece of land has been heavily farmed over a long period of time with crops that periodically, as you say, we're looking at those longer term moisture contents, there is a potential influence there, isn't there?
Yeah.
And with the increasing in, you went through the influence and the potential that we've got deepening of foundations. Is this now pointing to the southeast being more prone to piled foundations?
You could probably draw that conclusion, one would assume, because it's suggesting the rest of the country is happy days. But again, that does depend on the climate change predictions being correct. The geology of the UK would lend itself to the fact that the soils in the southeast are definitely the ones that are the highly shrinkable illite, montmorillonite rich clays, whereas the soils in the northern parts of the country are predominantly kaolinite rich. So the low shrinkability in the north and probably quite a high sand and granular content. So in the southeast of the country, you will be getting, like that diagram showed at the beginning with the 2070 diagram, being roughly 50% increase in the area. And so I think the quick answer is probably yes.
No, that's brilliant. That's brilliant. Right, I think we'll end the questions there because we're moving on with time now. But the further questions, we have had quite a lot of questions come in. It's obviously a very hot topic. So I'll ask Paul to answer those questions afterwards, and he'll get back to you once he's reviewed these. So as Paul said, our next Down to Earth talk will be on Tuesday, the 13th of August, and we're going to be focusing on the specification of topographical and measured building surveys and the challenges in getting a good survey which will support your site and development. Please remember to complete the feedback following the presentation, and thank you very much for attending today, and we'll see you again in August.